Alright guys, welcome back. We're in section 9.2.3. We're recapping sine, cosine, and tangent and its relation to the unit circle. So let's take a look at this. For any angle theta, the sine of theta, denoted by sine theta, is the y-coordinate of the point on the unit circle reached by a rotation of theta radians from the standard position, which is starting right here. Counterclockwise, starting from the positive x-axis. The cosine of theta, denoted by cosine theta, is the x-coordinate of the point on the unit circle reached by rotation of theta radians from standard position. And the tangent, denoted by tangent theta, is the slope of the terminal ray of an angle by rotation of theta radians in standard position. The Pythagorean identity says that sine squared plus cosine squared of theta equals 1, and it describes the relationship between the side lengths of a right angle formed in a unit circle with the radius of the hypotenuse. So just to sort of zoom in on this a little bit and recap, we started this off by saying that we have a unit circle that has a radius of 1. We see that radius of 1 here, and here, and here, and here, and any other ray that comes from the center out to the edge of the circle has a radius of 1. If we are going to find the x value and the y value for this triangle, and we know the radius is 1, then we can fall back on our trig functions, good old SOHCAHTOA, and we could say that the cosine of theta is equal to the adjacent side over the hypotenuse, so that would be x over 1. And when we have x divided by 1, we know that's the same thing as x, so the x value here is just cosine theta. Our sine function would say that the sine of theta is equal to opposite over hypotenuse, and our opposite here is y, and our hypotenuse is 1, so we would have y over 1. And again, if we have y divided by 1, that's the same thing as just y. So that gives us our y value of sine theta. So on the unit circle, the x's are your cosines, the y's are your sines. Also going back to SOHCAHTOA, we know that the tangent of theta is equal to opposite over adjacent. So if this is our theta right here, then the opposite side would be equal to the sine of theta, and the adjacent side would be equal to the cosine of theta, which lets us rewrite tangent as just sine over cosine, which also connects back to the slope of this line, which would be a rise of sine theta over a run of cosine theta, which would then give us sine over cosine again if we just went back to good old rise over run. Okay? And we can connect this to Pythagorean theorem by saying that x squared plus y squared equals our hypotenuse squared. In this case, our hypotenuse is 1. Our x squared is cosine squared theta. Our y squared is sine squared theta. And that gives us our Pythagorean identity, that cosine squared plus sine squared equals 1, because 1 squared is just 1. Alright guys, so just a little recap of a variety of things that we've talked about with unit circle this chapter. Hope that's a good refresher, and I'll see you next class.